get laid off this summer like I did last summer, then maybe that gives me more time in a sense to volunteer.
Here's the task that the differential analyzer is going to run.
But just are tight everywhere. Okay, see you later.
Okay, we're going.
So I'll start by explaining the problem that's being set on this machine, or differential analyzer, is a differential equation that represents the motion of a mass of a spring with some damping. The second order differential equation, so we require two integrators added to the machine. These units with the disk and integrators forming a mathematical function integrator. This particular problem we start out with an acceleration integrated to get the velocity, feed that to a second integrator to get position, and then establish a relationship between the position and the acceleration. That is accomplished through two adders built out of differentials in there that then mechanically add the rotation of two shafts together to perform simple mathematical operations of a plus or a minus sign. That combines the terms. The second term in the equation, which is the velocity dependent term, is coming through a third integrator here. This one is not being used as an integrator, just as a variable multiplier, where the ratio is set by the offset of the disk relative to the wheel, so that without having to reconfigure the interconnect of the machine here, we can change the amount of damping in the equation that the machine is solving just by manually setting the offset of this integrated disk. The third term into the adders over there is not actually being used right now, but would come from this input table. And the input table is a means whereby an operator can feed a graph into the machine while it's running. In that case, the machine would drive the table along one axis, and an operator would turn a crank to keep a crosshair on the curve to feed in the function of that independent variable that's driving the table. So the configuration here can be used to model the case that there's a forcing function in the system that kicks the system into motion. The results then get recorded on the output table, and what you can see on the table there is a decaying sine wave, which is the solution to this particular equation. The table can actually record two functions simultaneously. There are two pens on there, but it's only recording one right now. And it will take maybe 10 or 15 minutes to get the complete solution to the point where the motion is essentially decayed away. And then it will be possible to simply reset the machine by resetting the offsets of the various integrators, the appropriate set of initial conditions, and to run for a different solution. And that might be, we might vary the amount of damping, for example, within, or we might start from a different position and velocity variable. A certain amount of trial and error is required when you're setting up a machine, because you don't necessarily, if you're working on a problem where you don't already know the solution, and in real life that's of course what you would be doing, you have to make some estimate of the range of the variables involved, because the machine has physical limitations. The variables are represented by the rotations of shafts and the positions of these discs. If the variables go over too large a range, then you run off the end of the integrator, for instance. So you have to introduce scaling factors in the variables to effectively gear down the variables so that you don't fall off the end of the scale. So very often when you put a new problem on the machine for the first time, you can make an estimate of what you think the range of the variables are, but you have to run a solution to find out what the actual answer is, and if necessary make adjustments.
Okay, good. I got a picture of the ball bouncing over there, so
great.
They know the problem we're trying to solve. The only thing I wasn't getting was the damping. I wasn't getting the output on the thing very well.
Now, we get it from China? Or there was some story about McConnell doesn't make oil quality